students, my name is Teodros Kazao. I'm your physics teacher. Today we'll start the last unit on grade 10, that is electromagnetic waves and geometric optics. Let us start first from electromagnetic waves. What are electromagnetic waves? First, these electromagnetic waves are what? Transverse wave. Transverse wave, that means they are categorized under transverse waves. We'll see next what mean by transverse waves. And the second one is they are produced when magnets and electric field are what? At right angle to each other. That means it have both electric field as well as magnetic field, and these electric field and magnetic field are perpendicular to each other. Perpendicular to each other. Charges that are accelerate in an electric and magnetic field produced in electromagnetic waves, and also they carry what? Energy, moment, that means momentum, that may be transferred what? To matter with which they interact. Therefore, these electromagnetic waves carry energy as well as momentum, and they propagate both in vacuum as well as what? In a medium. That means they cannot or they do not need a material medium to propagate. They can also propagate or they can also move through a vacuum. The second one is mechanical waves. These mechanical waves are what? They can travel through a medium. That means they do not travel or propagate through a vacuum. But mechanical waves are they can travel through a medium, but they cannot or they do not travel in a vacuum. But electromagnetic waves are a wave that can travel through a vacuum as well as what? Through a medium. Therefore, they are different. This indicates mechanical waves need what? A material medium to propagate, but electromagnetic waves, they do not need a material medium to propagate. The other thing is they have what? Frequency, period, and amplitude. And let us see types of wave. We can classify the waves into two, that is electromagnetic and mechanical wave, depending on the material medium. But now we can classify waves into two depending on the direction of vibration and the direction of propagation. The first one is transverse wave, and the second one is longitudinal waves. Let us see this one by one. First, let us start from transverse waves. Transverse waves are a wave that can propagate through a vacuum, or they can propagate in perpendicular direction with the direction of vibration and propagation. That means waves that can vibrate or propagate perpendicularly. The perpendicular direction is between what? The direction of the wave. That means the direction of the wave propagate and what? Vibrate. For example, let us take one example. If we have some rope or string, and this string is attached in a straight line, if you make a vibration up and down, this string moves such a like until it reach the fixed point. Therefore, this string propagates to the right horizontal direction, and the vibration is what? Up and down, and this one is the vibration, and this one is the propagation. Therefore, the propagation and the direction of the vibration are what? Perpendicular to each other. Such wave types are categorized under transverse wave. And all waves are produced by vibration. This is for all waves. It's not only for transverse as well as longitudinal. And examples of this transverse wave, as we stated before, or electromagnetic waves are what? Examples of transverse wave. When we say electromagnetic waves, X-ray, microwave, radio wave, we can add here X-ray, gamma ray, ultraviolet, and radio wave, we say that in microwave, infrared. There are 7. 1, 2, 3, 4, 5, 6, 7. Therefore, this is often are electromagnetic waves. The other thing is definition terms. We can define some terms which we use in wave. The first one is amplitude. You have learned this on grade 9 of unit 8, that is wave and sound, wave motion and sound. On that unit you have learned about the definition of amplitude, frequency by classifying under wave characters. Therefore, amplitude is the distance that wave above or below the baseline or the equilibrium line, and this, since it is a distance, it's measured in what? Meter. And the second one is frequency, the number of what? Complete cycle in a given 1 second. In a given second means that in 1 second how many number of cycle is traveled by the wave in 1 second. For example, the unit for this frequency is hertz, and it's symbolized by Hz. For example, if the frequency is 20 hertz, this means that the wave travels what? 20 complete cycle in 1 second. Therefore, frequency indicates in 1 second how many complete cycle is moved by the wave, or the number of complete cycle per second is expressed by frequency. The other thing is wavelengths. We can define wavelengths in different ways. The first one is the distance between two successive equivalent points. When we say equivalent points, crest or what? Trough. For example, let us draw one wave diagram here. Let us say this one is the wave, and this, the peak point above the equilibrium point is named as crest, and below the equilibrium point is named as trough. And between the two successive troughs there is a distance, and this distance is wavelength lambda, or between two successive crests it is what? Lambda, or the distance traveled by the wave to complete 1 cycle. For example, if we start from this point and when we reach at this point, it's half a circle, and when we add this half a circle, you complete 1 cycle from this up to this. Therefore, this distance is also what? The wavelength lambda. Since it is a distance, it's measured in what? Meters. And the other thing is ray. Ray is what? A straight line extending from what? A single point to represent the direction of energy flow of a wave. The other thing is the wave equation. The wave equation relates the speed, wave speed, frequency or time period, and the wavelength lambda. Let us see this. The frequency, wavelength, and the speed of wave related by the formula. V is equivalent to, or speed is equivalent to, the product of what? Frequency times wavelength. And in symbol F times lambda. Or since frequency is equal to 1 over time period, we can also this express as V is equal to, in the place of F, 1 over time period times what? The wavelength lambda. This one gives us lambda over T is also another equation for the wave equation, because 1 over time period is equivalent to frequency. And V is the speed, F is the frequency, and lambda is the wavelength. Since it is speed, the speed is what? A distance traveled per unit time. We can use this equation. This wavelength is what? Distance, and T is time. Time period is the time taken to complete 1 revolution. Therefore, it's distance over time. And the other thing is the second types of wave, that's longitudinal waves. These longitudinal waves are a wave that vibrates in the same direction to the wave. For example, if we have a spring, let us say we have some spring. This one is a spring, and if you compress or rarefy this spring, this one is what? The vibration. After you compress, when you release the wave or the spring, if it is compressed, it's rarefied. If it is rarefied, it's what? Compressed. Therefore, this one is what? The direction of propagation or the direction of the wave which is created. Therefore, the propagation is, or the direction of the wave is what? Horizontal. Horizontal. It's to the right and to the left it vibrates, and the vibration is also what? Horizontal. And the direction of the vibration and the direction of propagation is what? Parallel. If they are parallel and in the same direction, or when we say the same direction, it means that it's parallel. Since it is parallel, we can classify under longitudinal wave. Therefore, wave on spring is one example of longitudinal wave. Here we expressed sound wave. We can also add wave on spring. Wave on spring. These are some examples of longitudinal wave. And electromagnetic waves emitted by the sun. There are 7 electromagnetic waves which is emitted by the sun. They have what? Wide continuous range of frequency. The 7 electromagnetic waves emitted by the sun is what we take as an example on transverse waves. The 7 light spectrums. Okay, they have wide continuous range of what? Frequency and wavelengths. They have a difference in frequency and wavelengths, and this is called electromagnetic spectrums. Electromagnetic spectrums. And electromagnetic spectrums, the entire frequency range of the wavelengths. And in the vacuum, all waves are traveling at a speed of how much? 3 times 10 to the power of 8 meters per second. Therefore, if the wave is electromagnetic wave, the wave equation, which is equal to V is equal to lambda times frequency, is changed to C is equal to what? Lambda times frequency, where C is what? 3 times 10 to the power of 8 meters per second. Because since it is electromagnetic wave, all electromagnetic waves are traveling with what? A speed equivalent to 3 times 10 raised to 8. Therefore, this speed V is changed to what? C, speed of light. As we go from left to right, the frequency decreases, whereas the wavelength increases. And the reverse is also true. In the reverse, the wavelength decreases and the frequency increases. The energy also decreases when you go from left to right. Some of electromagnetic radiations, and the first one is visible light, is the most important part of electromagnetic spectrum to everyday life, because we can't see everything without this visible light. To see an object, a light must be reflected from the object and back to your eye. If this light is not present, we can't see anything. Therefore, these visible lights are the most important electromagnetic wave or spectrum to everyday life. The other thing is X-ray. X-ray is used to take pictures. For example, to take X-ray for some broken backbone or for lung disease and for other features. And the other thing is they are what? They are absorbed more by bone, which is denser than the surrounding muscle. Therefore, we can use this is for X-ray. They are absorbed by the bones more than the muscle. Therefore, the picture of the bone is easily extracted by X-ray. The other thing is infrared. Infrared radiation is used in infrared cameras, which are used rescue operation to detect the presence of body and so on. Microwave and radio waves are also used for communication. For example, microwaves are used in telecommunication and radio waves are used for radio stations. And the other thing is, among the wave behavior, today we will see about one wave behavior. Wave have 4 behaviors: reflection, refraction, diffraction and interference. Among these, we will see the reflection one. Reflection of light and rectilinear propagation of light is simply mean that what? The light wave traveling in straight line. And reflection means the bouncing of light ray from what? Non-transparent or an obstacle. Sometimes we can call this medium non-transparent or obstacle. From some obstacle. Obstacle means that cannot absorb and transfer light or ray, that only what? Reflects. When this light is incident to this non-transparent or on an obstacle, it reflects back, and this situation is named as reflection. As you see, this one is non-transparent material or an obstacle, and this ray is incident ray. That means the ray which is coming to an obstacle, and the middle line, the broken line, is named as the normal line, and reflect back, and this ray is the reflected ray. That means after the incident ray is reached the surface of this obstacle, it reflects back, and the reflected back ray is this one, and it's named as what? Reflected ray. And we have two laws of reflection. The first one indicates the angle of incident and reflector. Let us see this. Here, always when we measure the incident and the reflected angle, you must measure from this normal line. This is not theta incident. This is not theta incident. The incident angle is not this one. The incident angle is measured from the normal line. Therefore, this one is theta incident. This one is right. And here also the reflected angle is also measured from the normal line. Therefore, this one is theta reflected. But this one is not theta reflected, or the reflected angle. Therefore, when you measure the incident and the reflected angle, you must measure from the normal line. And the first law states that the incident ray is equivalent to the reflected ray. They are equivalent. And the second law, this one is the first, and the second law states that the incident ray, the reflected ray, as well as what? The normal line lies on the same plane. As you see, the reflected ray, the incident ray, and the normal line lies on the surface of the obstacle or non-transparent material. Therefore, this one is the second law. As you see, the first law, theta r is the reflected, and theta incident is theta I is the incident. Both are what? Equivalent. And theta I the angle of incident, theta r is the angle of reflected of that of the propagation in the same medium. And the second one is the reflected ray, the incident ray, and the normal line lies what? In the same plane. These are the two laws of reflection. This is all about today. Until next time.